Hey folks, so for this is question 8. So Jessica is making up a solution of acid. Okay, so she's got two bottles, and one of them, so it's the same acid that's in both of them. But bottle A, it has a concentration of 12%, and in bottle B, it has a concentration of 5%. So bottle A is stronger by a good bit. So, uh, for example, in every 100 milliliters of liquid in bottle A, there's 12 mils of acid. All right. So work out how many mils of acid are in 200 mils from bottle A. So if for 100 there's 12, then for 200 there has to just be double that. So uh, all you have to do here is you have to double 12, so 2 times 12, so that's 24. So if for 100 there's 12, then for 200 there has to be 24. So that's for question A, or for part of question A. The second part, so she mixes 200 mils of liquid from bottle A. All right, so you know already from 200, there's kind of 12 plus 12. There's two 12s really from bottle A. And so she mixes it with 300 mils of liquid from bottle B. So if you look at bottle B here, each one of those 100 mils has 5% in it. So if there's three different 100 mils, then there's three different 5%. So she adds on three 5% basically. So that's all of the acid then. That's all the concentration of acid. So if you add all them together, you get 39. So we're going to put 39 over the total to work out the percentage. So the total then, she mixes 200 mils with 300 mils. So 200 and 300 is 500 altogether. And then, so that's it really. And then turn it into a percentage. That's it as a fraction, turn it into a percentage. You times by 100 or times by 100 over 1. So you do 39 500 times 100. And we're getting 7.8. So it'd be 7.8%. That's the second part. Explain why she could not make a solution with a 4% concentration of acid by mixing liquid from bottle A and bottle B. Um, it's because it has to be somewhere in between the 5 and the 12, because if there's 12 in bottle A and 5 in bottle B, you can't ever make it so that it's going to be less than 5 or it's going to be more than 12, because it's a proportion of the total. So it's because it's somewhere between 12. Um, so the fourth part, when she is making another mixture, she makes a mistake in measuring. She wants to measure out 250 mils, but she measures out 260 mils instead. So work out the percentage error in this measurement. Right, so uh, she's out by 10 basically. So it's going to be 10, and you're going to put it over the total then of what it has to be the total of what it should be. So because that's what she's measuring. So 10 over 250 times by 100. So she's out by 10, put it over 250 and times by 100. So you get 4%. So 4% she's out by. Right. Question B then is different. It's about with shapes really. So if a solid is made up of faces with straight edges, then the following identity is often true. C minus E plus F equals 2. So where C is the number of corners, E is the number of edges, and F is the number of faces. So write down the values of C, E, and F for a cube. All right, so C, so corners on a cube. So you might know already that there's going to be 8 corners. So there's one there, 2, 3, 4, 5, 6, 7, and then there's one that you can't see. It's kind of down in the corner like that. So 8 corners. Faces then, there's always 6 faces on a cube. So there's one there in front, and then there's one identical one on the back. There's one on the top like that, and then there's one identical one like that on the bottom. Well, they're all identical, I know, but base in it, I suppose. And then there's one on the side, and then there's one across from that on the other side. So there's 6 altogether. So we have to do C minus E plus F. So 8 minus 12 plus 6, and that should equal 2. Was equal to, so 8 minus 12 is minus 4, and add on 6 is 2 positive 2. So each of the faces of a different solid in a shape of a triangle is in the shape of a triangle of area 5 centimeters squared. So this solid has 12 corners, 30 edges, and C minus E plus F equals 2. So for this solid, work out the surface area. So to work out the surface area of anything, you have to find the area of one of the faces of it, and then, well, you have to find out the area of each of the faces and add them all together. Now, you know all of the faces in this are the same. They're all a triangle of area 5 centimeters. So it's just, we have to figure out how many faces it has and then add them all together or multiply that by 5. So C minus E plus F equals 2. So the problem here is that we don't know how many faces the shape has. It could have any amount of faces. But we're given this equation and we're told how many corners and how many edges it has to help us work it out. So it has 12 corners. So if I sub in 12 for C, corners, minus, and 30 for edges, plus F equals 2. So you can kind of figure it out in your head almost, or you can treat it as an equation. So 12 minus 30 would be a minus 18. Equals 2. And then if we add on 18 to both sides, or move the minus 18 over, you're going to add on 18 to 2, so you're going to get F equals 20. So the number of faces is 20. So this is a shape with 20 faces, and they all have area of 5. So it's something like that. It's some kind of a shape like this, but it has 20 of those triangles, and they all have the same area. So I mean, I've only drawn loads of triangles here, but it's some kind of shape that looks something. I don't know. It probably doesn't look like that, but that's kind of the idea. It has 20 different triangles of area 5 centimeters. So we have to just do 20 times 5, which is 100. So 100 centimeters squared. Right, the surface area. Oh, yeah, so this is one of the harder questions again. So the surface area of a third solid is made up of H pentagons and H hexagons and P pentagons, where H and P are natural numbers. So it gives us this big equation. So use this equation to find the number of pentagons in the surface of this solid. So I've seen this before, this question just before, and the problem here, it's actually quite simple if you don't overcomplicate it. What most people do, because it has H and it has P in it, people get confused, and it has two different variables, so they're not really sure how to do it. One way you can do it is you can start subbing in numbers in for H and in for P. Um, So, um, P has to be a kind of a multiple of 5, and H has to be a multiple of 6, because there's 6 sides in a hexagon. Uh, the simplest way of doing it, and most straightforward, obviously, way of doing it is you just solve it as if it's a normal linear equation. What actually happens is that the h's will cancel out. You don't know that before you start. So most people go off and they try to simultaneous equations, or they try to trial and error, or just try and look for numbers, just subbing in numbers in. Um, but if you try and solve it as a linear equation, it'll work out. So what I'm going to do here anyway is I'm going to multiply everything across by 6. Okay, so you'll get, if you multiply this part by 6, it'll, the 6 and the 3 will cancel out, so you'll have to multiply the top by 2. So we end up getting 2 times 6h plus 5p minus, and then I'm going to multiply this part here by 6. So if you multiply that by 6, the 6 and the 2 will cancel, so you're left with 3 on top. So 3 times 6h plus 5p. And then plus, I'm just multiplying both of these by 6 then, so plus 6h plus p equals, and then you have to multiply the 2 by 6, which is 12. And then you're left with, we're going to keep going. You still have h's and p's in it at the minute, so 2 times 6h is 12h, 2 times 5p is 10p, minus 18h minus 15p plus 6h plus 6p equals 12. And then, so notice what happens here then. Just look at the h's. So you've got a 12h, you've got a minus 18h, and you've got a plus 6h. 12 minus 18 plus 6 is 0. So what happens is the h's cancel out here. Because if you put them all together, add them all together, it ends up as 0. So the h's are kind of cancelled themselves out, so you don't have to do anything to get rid of the h's, which works out nice. And then you've got 10p minus 15p plus 6p equals 12, and this works out nicely then as well, because you get 10 minus 15, which is minus 5, and then you add on 6, which is 1, so you get 1p, or just p, so you get p equals 12. Well, it actually doesn't end up being that much work, the whole question. It works out really nicely. You just have to kind of plow through it as if it's a linear equation. So it's a sneaky enough kind of question, because when you see two variables in a question like that, straight away you're thinking, I need to figure out one of them and sub it in and so on. But the H is cancelled out for you. So that's question 8.